Welcome to a deep dive into a theory so mind-bending, it might just reshape your understanding of reality.
Absolutely.
We're exploring excerpts from Unified Quantum Information Network Theory,
A framework that proposes a universe built not just from particles and forces.
but from a network of quantum information.
That's right.
Buckle up. This is where things get really interesting.
It really is. This theory suggests that instead of a universe solely dictated by the laws of physics as we understand them,
There's something more.
yeah, everything is fundamentally interconnected through a web of relationships.
So instead of focusing on individual particles,
Yes.
this theory emphasizes the connections between them.
Yes.
It's about the network, not the nodes.
Precisely. At the heart of this idea lies the relational universal wave function.
Okay.
You can think of it as a blueprint
Uh-huh.
containing all possible states of the universe. But here's the twist.
Okay.
The components of this wave function aren't isolated.
They're not.
They're all linked together in a complex web of relationships,
Really?
forming a structure called a hypergraph.
A hypergraph. That sounds complicated. Can you break that down a bit?
It's simpler than it sounds. A regular graph connects pairs of points. Think of a social network. Each person is a point, and the connections between them represent friendships.
Okay, I got it. So like who's friends with who?
Right, but a hypergraph can connect any number of points simultaneously, forming more complex relationships.
Okay.
In this theory, the hypergraph represents the interconnectedness of everything in the universe.
So it's like a cosmic social network where everything is ultimately connected to everything else.
That's a good analogy. This hypergraph dictates how information flows throughout the universe, influencing the probabilities of events.
But how does that actually work? How can these relationships influence events across vast distances?
That's where the information entanglement field comes in.
Okay.
Imagine a field similar to the Higgs field, which gives particles mass. But instead of mass, this field entangles particles across vast distances.
Entanglement. That's where two particles are linked in such a way that they influence each other instantaneously.
Right.
No matter how far apart they are. It's one of those mind-boggling aspects of quantum mechanics that always makes my head spin.
You're on the right track. To understand how this field works, we need to talk about Hilbert space. Picture it as a multidimensional space,
Okay.
containing all possible states of a quantum system.
Yeah.
This field connects and entangles particles across this vast Hilbert space, influencing the probabilities of quantum events.
So this field acts like a giant cosmic puppeteer, subtly guiding outcomes within the realm of quantum mechanics.
It's more subtle than that. Think of it as a gentle nudge within the system,
Okay.
influencing probabilities but not violating any fundamental laws of physics.
So it's not forcing outcomes, it's just making certain outcomes more likely than others.
Exactly. Now imagine this entanglement field emerging during the Big Bang,
Okay.
establishing the initial connections between particles, and setting the stage for the universe as we know it.
So the Big Bang wasn't just an explosion of matter and energy, it was also the birth of this intricate network of relationships.
Precisely. And this field isn't static.
Right.
It's constantly evolving and learning based on quantum events influencing the future trajectory of the universe.
So the universe isn't just following a predetermined path. It's constantly adapting and exploring new possibilities based on this web of relationships.
That's one of the most fascinating aspects of this theory.
I can imagine.
It suggests that the universe is far more dynamic and interconnected than we previously thought.
But if everything is entangled and probabilistic,
Right.
why do we experience a stable, predictable reality?
Right.
Why don't we see quantum weirdness all the time?
That's where quantum Darwinism comes into play.
Okay,
Through the entanglement field, only stable configurations of quantum states survive and propagate.
they do.
It's like natural selection for quantum systems.
So the configurations that can withstand the chaotic quantum world are the ones that stick around creating the consistent reality we perceive.
Precisely. Think of it this way. In the quantum world, things exist in a superposition of states. They can be in multiple states at once.
Okay.
But when these quantum systems interact with their environment, they tend to choose one state, a process called decoherence.
So decoherence is like a transition from the weirdness of the quantum world to the stability of the classical world.
That's a good way to put it, and it's not a sudden switch, it's more of a sliding scale. Decoherence depends on the scale and context of the system.
So while decoherence is prevalent at larger scales, explaining why we don't see objects in multiple states simultaneously, quantum coherence can still exist in specific environments, like within living organisms, or in carefully controlled lab settings.
Exactly. And this leads us to another fascinating concept, contextual decoherence. Quantum systems transition to classical-like behavior through interactions with their environment.
So it's not just the inherent properties of a system that determine its behavior, but also its relationships with the world around it.
Precisely. The environment plays a crucial role in shaping how quantum systems behave.
This reminds me of the philosophical concept of Kantian wholes, systems where the parts are intrinsically linked and work together to form a unified whole.
That's a great connection. Examples of Kantian wholes can be seen in nature, like a flock of birds moving in perfect synchronization or a school of fish changing direction as one. These systems exhibit collective behavior that can't be explained solely by individual actions.
So the parts are working together in a way that creates a new emergent property of the whole. And this information entanglement field provides a mechanism for these Kantian wholes to exist.
That's the idea. The field acts like an invisible glue, binding these systems together and allowing them to function as a unified whole. But it's not just about how systems are connected, it's also about how information flows between them.
So how does information move through this field? Is it like a signal traveling through a wire?
It's more nuanced than that. Quantum state information doesn't flow in a rigid, deterministic way. It propagates probabilistically influenced by the strength of relationships between systems.
So the closer the relationship, the faster and more reliably the information travels. Is it like a rumor spreading? The closer you are to the source, the quicker you hear the news.
That's an excellent analogy. And this leads to another intriguing concept.
Okay.
Distributed self-referential observation.
Okay, that sounds complex. Can you break that down for me?
Essentially, quantum systems aren't just passively observed. They play an active role in their own decoherence through interactions with their environment.
So it's a two-way street. The system influences its environment, and the environment influences the system.
Exactly. And this self-referential process happens across multiple scales, creating a multi-layered reality.
Okay.
It's a constant feedback loop, a dance between the quantum and classical worlds.
This is such a mind-bending shift in perspective. So if entanglement can link things instantaneously across vast distances, how does new information actually propagate through this field?
That's a great question. While entanglement might seem to act instantaneously, the propagation of new information through the field appears to be bounded by the speed of light.
So even though entanglement can connect things instantly, new information still has a speed limit.
Yes.
That makes sense, given Einstein's theory of relativity.
Precisely. And this has fascinating implications for the universe. It suggests that there are isolated innovation zones where different regions can independently explore possibilities without immediately influencing each other.
So different parts of the universe could be developing unique patterns and solutions in isolation.
Yes.
It's like a cosmic laboratory with different experiments running in parallel.
That's a great way to think about it. And when these previously isolated regions eventually come into contact, their independently developed quantum patterns can interact and recombine, leading to even greater diversity and complexity.
That's incredible. So the universe is constantly experimenting with new possibilities, and the speed of light acts as a buffer, allowing for more diverse outcomes.
Exactly. And all of this points to the idea of emergent reality. Our familiar classical world arising from this intricate dance between quantum behavior information flow and the self-referential nature of the universe.
It's mind-boggling to think that our everyday reality emerges from this complex interplay of quantum phenomena. But if everything follows these probabilistic functions dictated by quantum mechanics,
yes,
where does free will come into play?
Yeah.
If everything is ultimately determined by these interactions,
right,
do we really have any choice in our actions?
That's where the concept of degrees of freedom in quantum interactions comes in.
Okay.
While quantum interactions follow probabilistic functions, there's still a bit of wiggle room, a space for the entanglement field to exert its subtle influence.
So there's a bit of flexibility within those quantum rules, a space for something else to nudge things along. But how does this connect to free will?
It's a complex question, and the theory doesn't offer a definitive answer. But it suggests that free will might not be about breaking the laws of physics, but about operating within those degrees of freedom,
Okay.
those subtle nudges within the system. It's about how the entanglement field navigates the probabilistic landscape of quantum mechanics.
That's a fascinating perspective. It's not about defying the rules, but about playing the game in a skillful way.
Right.
It suggests that free will might be more about subtle influence than absolute control.
Exactly. And this leads us to another intriguing concept, connection to adjacent possibles.
Okay.
Picture a landscape of potential states the universe can explore. Each point on the landscape represents a different possible state for the universe.
I can picture that, but how does the universe decide which path to take on this landscape of possibilities?
That's where the information entanglement field comes into play.
Okay.
Each quantum event opens new possibilities while closing off others, shaping the landscape of adjacent possibles.
So the universe isn't following a predetermined path. It's constantly exploring new possibilities based on the information flowing through this field, this web of relationships.
Precisely. This model suggests that unpredictable novelty and complex structures can emerge in a universe governed by both quantum possibilities and classical constraints. It's like the universe is constantly improvising, creating something new and beautiful along the way.
This theory is truly mind-blowing. It reimagines the universe not as a collection of isolated objects, but as an interconnected web of information and relationships, a cosmic dance of possibilities.
And we've only just begun to explore the implications of this radical new perspective.
I bet.
It challenges our fundamental assumptions about reality, consciousness, and even free will, opening up exciting new avenues for scientific exploration.
I feel like we've just scratched the surface of this theory. But before we dive deeper, let's take a moment to let these ideas sink in. We'll be back soon to explore more mind-bending insights from the Unified Quantum Information Network theory.
Don't go anywhere. There's much more to discover.
Welcome back. I trust you've had a moment to process some of those groundbreaking concepts from the first segment.
For sure.
We're delving deeper into the Unified Quantum Information Network theory, a framework that reimagines our understanding of the universe.
I'm still wrapping my head around the idea of reality as a vast web of quantum information,
Yeah.
a cosmic dance of interconnectedness.
Right.
It's a truly paradigm-shifting concept.
It is, and one of those fascinating aspects of this theory is
How it tackles
some of the biggest mysteries in quantum mechanics.
Yeah.
Those perplexing paradoxes that have puzzled physicists for decades.
You're talking about things like the measurement problem, right?
Exactly.
The idea that the act of observing a quantum system forces it to choose a definite state. It always felt a bit strange that consciousness could have such a direct impact on the physical world.
The traditional Copenhagen interpretation of quantum mechanics does suggest that the observer plays a role in collapsing the wave function.
It does. But this theory offers a different perspective. Remember how we discussed contextual decoherence?
Yes.
Instead of the observer causing the collapse, the quantum system interacts with its environment,
Okay.
leading to decoherence and the emergence of a classical outcome.
So it's not about consciousness directly influencing the outcome,
Right.
but about the system's interaction with its environment.
Right.
The observer becomes just another part of that environment, another node in the network.
Precisely. Observation is simply a process that unfolds within the network of quantum information, with the observer being another participant in this intricate dance.
This perspective also sheds new light on Schrödinger's cat thought experiment.
Yes.
The poor cat, both alive and dead, until someone opens the box.
Right.
It always seemed like a cruel cosmic joke.
In the traditional interpretation, the cat's fate remains uncertain until an observer intervenes. However, in this framework, the cat isn't suspended in some quantum limbo. It's constantly interacting with its environment inside the box. Those interactions are driving the decoherence process, pushing the system towards a definite outcome, even without an external observer.
So the cat's fate isn't determined by the observer opening the box. It's unfolding based on its relationships within the box, within that closed system.
Precisely. The observer simply reveals the outcome that has already been determined through these complex quantum interactions.
This reframing of the measurement problem is really thought-provoking.
I think so.
It removes the observer from a privileged position.
Right.
And places them back into the web of relationships that governs the universe. But it also raises another huge question.
Yes.
If reality is this interconnected web of information, what does that mean for our understanding of consciousness?
Right.
Does this theory offer any insights into how consciousness arises?
That's a profound question, and one that the theory is actively exploring.
Okay.
Recall our discussion of distributed self-referential observation, where quantum systems participate in their own decoherence? Some proponents of this theory suggest that consciousness might emerge in a similar way.
It might.
Imagine consciousness not as a thing localized in a specific part of the brain, but as a higher-order pattern of information flow within this universal network.
So instead of consciousness being confined to the brain, it could be a more distributed phenomenon,
Yes.
a property of the network itself.
Yeah.
That's a radical departure from traditional views of consciousness.
It is. And the more complex the network of relationships, the more sophisticated the emergent consciousness could be. This could potentially explain the spectrum of consciousness we observe in nature, from simple organisms to the human mind.
This is a truly awe-inspiring concept.
It is.
It suggests that consciousness isn't something separate from the universe, but rather a fundamental aspect of its fabric, woven into the very essence of reality.
It challenges us to reconsider the relationship between mind and matter.
Okay.
To see consciousness not as something that arises from the material world, but as something that co-evolves with it, shaping and being shaped by this intricate web of quantum information.
This theory is opening up entirely new avenues for exploring the nature of consciousness. But let's bring it back down to earth for a moment.
Okay.
How might this theory impact our everyday lives? Does it change anything about how we experience the world?
While the full implications are still being explored,
Right.
this theory offers a profound shift in perspective.
It does.
It suggests that we're not isolated individuals, but deeply interconnected nodes within a vast network of information and relationships.
Okay.
Our actions, thoughts, and even our existence contribute to the constant flow of information shaping the universe around us.
So we're not just passive observers of the universe, active participants in its evolution. Every choice we make, every action we take sends ripples through this network,
Yes.
influencing the unfolding of events.
It's a humbling yet empowering thought. We're all part of this grand cosmic dance.
I like that.
And our individual steps influence the rhythm and flow of the universe. It invites us to consider the impact of our choices and to act in ways that benefit not just ourselves, but the entire network.
It's a call to move beyond self-interest and to embrace a more interconnected, collaborative approach to life.
Precisely. Recognizing our interconnectedness can profoundly impact how we relate to each other, to the natural world, and to the universe as a whole. It's a shift from a mindset of separation to a mindset of unity.
This theory isn't just about physics and information. It's about how we understand ourselves and our relationship to the universe.
Right.
It's about recognizing that we're all part of something much greater than ourselves.
It's about embracing the awe and wonder of a universe where everything is connected,
Yeah.
where information flows like a cosmic river,
I like that.
and where consciousness emerges from the intricate dance of quantum possibilities.
This is a truly transformative perspective. And speaking of transformations, where does this theory go from here? What are some of the exciting avenues of research it opens up?
The possibilities are vast.
I bet.
For starters, this framework could lead to breakthroughs in quantum computing and communication.
Okay.
Imagine harnessing the power of entanglement to create ultra-secure communication networks, or to solve complex problems that are beyond the capabilities of classical computers.
We could be on the verge of a technological revolution driven by a deeper understanding of this information entanglement field. A world where quantum computers could simulate complex systems with unprecedented accuracy, from ecosystems to climate patterns to even the human brain.
Exactly. And on a more philosophical level, this theory could revolutionize our understanding of consciousness, free will, and the nature of reality itself. It could bridge the gap between science and spirituality, offering a unified view of the universe that encompasses both the material and the immaterial.
It's like we're standing on the precipice of a new era of scientific discovery, an era where the boundaries between physics information theory and consciousness begin to blur, leading to a more holistic and interconnected understanding of the universe.
Precisely. This is a time of great intellectual ferment, and the unified quantum information network theory is one of the most exciting and thought-provoking ideas to emerge in recent years. It's a theory that invites us to think bigger, to question our assumptions, and to embrace the mystery and wonder of a universe far more interconnected and awe-inspiring than we ever imagined.
We've covered an incredible amount of ground today exploring concepts that push the boundaries of our current understanding. But we're not done yet. When we return, we'll delve into some of the potential implications of this theory and discuss how it might shape our understanding of the future.
Stay tuned. The journey into the heart of reality continues.
Welcome back to our deep dive into the unified quantum information network theory. We've been on quite a journey exploring this idea of a universe woven together by a web of quantum information.
It's a framework that challenges our very understanding of reality,
It really does.
suggesting that everything from the smallest particles to the largest structure
To the largest structures,
is interconnected through a network of relationships.
we've talked about entangled particles of cosmic neural networks,
We have.
and even the idea that consciousness might emerge from this intricate web. But now I want to shift our focus to the future. What are the potential implications of this theory? How could it shape our understanding of what's possible?
The implications are far-reaching,
I can imagine.
touching everything from technology to philosophy to our very understanding of ourselves and our place in the cosmos.
So where do we even begin?
Well, let's start with the practical side. Could this theory lead to new technologies or innovations?
Okay.
Absolutely.
Okay.
One area where this theory could have a significant impact is problem solving. If we begin to view challenges not as isolated incidents,
Not as isolated incidents.
but as interconnected nodes within a larger network,
Okay.
we might discover entirely new solutions.
So instead of trying to fix things in isolation, we could look for leverage points within the network,
Right.
places where small changes can have cascading effects throughout the system.
Precisely. Imagine approaching a complex issue like climate change,
Climate change.
not just as an environmental problem, but as a symptom of a deeper imbalance within the network of human systems and the natural world.
By understanding the interconnectedness of the system, we might find more effective and sustainable solutions that address the root causes, rather than just treating the symptoms.
Exactly. And this interconnected approach could also extend to our understanding of technology. Remember how we talked about quantum computing?
Yes.
Imagine harnessing the power of entanglement to create computers capable of modeling complex systems with incredible precision.
So we could simulate the behavior of ecosystems, predict climate patterns with greater accuracy, or even model the intricacies of the human brain.
Right.
The possibilities are astounding.
The theory could also revolutionize communication and energy production.
Energy. How does this theory connect to energy?
Well, if reality is fundamentally a network of information,
Okay.
then perhaps energy itself is simply a manifestation
Of information flows.
within this network.
So instead of viewing energy as a separate entity, we could see it as an emergent property of this interconnected web of information.
Precisely. And if we could understand how information shapes energy flow,
Yeah.
we might unlock entirely new sources of clean and sustainable energy. We might even learn to tap into the very fabric of reality to power our world.
That's an incredibly exciting prospect. But the implications of this theory go far beyond technological advancements.
I agree.
It also challenges us to reconsider our place within this network.
It does. If everything is interconnected, then our actions ripple through the network, impacting not just ourselves, but the entire system. It's a call to recognize our interconnectedness and act in ways that benefit the whole.
It suggests that we have a responsibility to act in ways that promote harmony and balance within the network, rather than pursuing self-interest at the expense of others.
Precisely. It's a shift from a mindset of separation to a mindset of unity.
From competition to collaboration.
Exactly.
This theory is truly transformative. It's not just about physics and information.
Yeah.
It's about how we understand ourselves and our relationship to the universe.
Yeah.
It's about recognizing that we're all participants in a grand cosmic dance. Our individual actions contributing to the unfolding story of the universe.
It invites us to see the world with new eyes, to appreciate the interconnectedness of all things, and to act in ways that nurture the well-being of the entire network.
This has been an incredible exploration. We've delved into mind-bending concepts that challenge our understanding of reality and our place within
We
it.
have. We've explored the idea of a universe where information is fundamental, where relationships are paramount, and where even consciousness might be an emergent property of this intricate web of connections.
As we conclude this deep dive, I want to leave our listeners with a final thought to ponder. If reality is truly a network of quantum information, what does that imply about the nature of consciousness and our place within this vast, interconnected universe?
Keep exploring, keep questioning, and never lose your sense of wonder. The universe is a vast and mysterious place, and there's still so much to discover.
Thank you for joining us on this incredible journey. Until next time, keep those minds open and those imaginations engaged.